In this video, I am going to evaluate this integral. We are given f of x is equal to cosine of x, and we need to evaluate integral 0 to pi over 2 x square f of x dx. To evaluate the integral, first I am going to find the indefinite integral, which, by the way, is going to be this integral x square f of x dx. Now f of x is given to be cosine of x, so this becomes x square cosine of x dx. Now this integral, by the way, is kind of a standard integral where we integrate by parts. So it's integration by parts. Remember, integration by parts tells you the following: integral u dv is equal to uv minus integral v du. Here we have to carefully select u and dv. In our case, we select u to be x squared. In that case, du over dx is going to be just 2x, or we could write du is equal to 2x times dx. Now my dv, by the way, is going to be this. dv is equal to cosine of x. Now if I integrate both sides, integral dv is equal to integral cosine of x dx, then I get v is equal to sine of x. Now I am going to apply integration by parts, which is this one. So that's going to give me the following: integral x square cosine of x dx is going to be uv minus integral v du. Remember, u is x square, so x square, my v is sine of x, so it's going to be x square sine of x minus integral v du. Now v is sine of x, and du, keep in mind, we found it to be 2x dx, so it's going to be 2x dx. Now if I rewrite it, I get the following. So after simplification, we get to this point, which is very straightforward. There is nothing magical here. It's very simple. So I just write the right side, and this is what I get. Look, this 2, I pull it outside. Now let's go ahead and look at this integral. Now this integral can be actually done again using the integration by parts. So that's what we are going to do. Now I'm going to apply integration by parts again. In the first case I applied it once, now I'm going to apply it second time. Now this time my u is going to be x, so my du over dx, du is going to be equal to just dx, okay, and my dv is going to be sine of x, dv is equal to sine of x. Now integral dv is going to be integral sine of x dx. Now remember, integral sine of x is negative cosine of x, right? Now integral dv is just v, so we get v is equal to negative cosine of x. So my integral x sine of x becomes uv. I am applying this uv minus integral v du. So u is x, v is cosine of x, so negative x cosine of x, then minus integral v du. What is v? Negative cosine of x, du is dx, which I could further simplify, and if I simplify, I get the following. So let's look at it how I simplify it. So negative cosine of x and negative, so negative and negative is going to make it positive, so integral of cosine of x, and then negative x cosine of x, negative x cosine of x. However, integral cosine of x is just sine of x, right? So what I'm going to do, I'm going to take this guy, look, integral x sine of x, and that is equal to this value. Now I'm going to take this value and plug it in right here. Then I'm going to get my integral x square cosine of x dx. So my integral x square cosine of x dx becomes x square sine of x, right? So x squared sine of x minus 2 times the integral of x sine of x, which is negative x cosine of x plus sine of x. Now I'm going to simplify it. If I simplify it, I get the following. It's going to be x square sine of x. Negative and negative is going to make it positive, so it's going to be plus 2x cosine of x, then minus 2 sine of x. Right? Now, of course, there is a constant here, so I'm just going to put the constant of integration, right? So this is what my integral x square cosine of x dx is. Now I need to evaluate it from 0 to pi over 2. If I do the evaluation, this is what I should get. Just keep in mind this constant is going to actually go away because we are going to be subtracting c and adding c, so that doesn't matter really. So we need to evaluate it from 0 to pi over 2. So x square, so pi over 2 is going to be pi over 2 whole square times sine of pi over 2 plus 2 times pi over 2 times cosine of pi over 2 minus 2 times sine of pi over 2. Okay, so this minus, I'm ignoring the c constant for 0. So if x is 0, so the first term is going to be 0 plus the second term is going to be 0 minus 2 times sine of x, sine of 0 is 0, so it's going to be all zeros. Now I just need to simplify it. So this whole thing is just 0. I'm subtracting 0, so I can just ignore that thing. So pi over 2 square is pi square over 4, right? Sine of pi over 2 is 1, so pi square over 4 times 1 is just pi square over 4 plus 2 to cancel out, but we don't need to worry about it. Cosine of pi over 2 is 0. Okay, so this is going to be 0 minus 2 times sine pi over 2. Sine pi over 2 is 1. So this becomes nothing but pi square over 4 minus 2. So my integral 0 to pi over 2 x square cosine of x dx is going to be pi square over 4 minus 2. So that's what the final answer is. Okay. Now let me just summarize what I have done so that you get a better understanding. So basically what I have done is used integration by parts. Okay. I used integration by parts repeatedly. I used it twice to find the indefinite integral, and then I took the indefinite integral, which is right here, okay, and then I evaluated from 0 to pi over 2. Okay, after evaluation, this is the value I get. I hope that this discussion was helpful. Thank you very much.